Okay, so in this problem, we're told that train A runs back and forth on an east-west section of a railroad track, and its velocity is measured in meters per minute. It's given by the differentiable function v sub a of t, and t is measured in minutes, and selected values for the velocity are given in this table. So we have t is 0, 2, 5, 8, 12. Here are the velocities. At time t equals 2, the train's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving the integral that gives the position of train A in meters from the origin station at time t equals 12. Use a trapezoidal sum with 3 subintervals indicated by this table to approximate the position of the train at time t equals 12. Okay, so the idea is that we need to figure out how the train's position changes from time t equals 2 to time t equals 12. We need to figure out what happens to its position. And for that, we're going to basically refer to the concept of displacement. Displacement is simply how an object changes its position. So, like, how does an object, move from, like, maybe it's position 0 at time t equals 0, and it moves 10 feet to the right, and so its displacement is 10 feet. The displacement could be 0, it could be 10 feet to the right, and then 10 feet to the left, so it's back at the original position, so the displacement is 0. So we want to see what the displacement is of the train from time t equals 2 to time t equals 12. Then we can basically figure out where it is from this original position of 300 meters east. So displacement is simply the integral of the velocity function over an interval, so over an interval from a to b. It's that simple. You don't have to worry about finding like zeros or absolute values or whether this velocity function is going to be positive. You just have to integrate it. Now, we're not given an explicit expression for velocity. We're given, values. So what we're going to do is we're going to draw like a graph, and so we can get a picture of what is going on here, so we can get a better sense of how we are going to solve this. So let's draw t. Let me make this actually wider. Our horizontal axis and our vertical axis for v of t, and time will go from, we'll have a t00, we're going to have it 2, call that 5, call that 8, call that 12. So it's at 0, 0, and it's at 2, 100. So we'll say that's 2, 100. And 5, 40, so maybe like there. And 8, negative 120, so maybe over here. And 12, negative 150. Now, since we know, this velocity function is going to be continuous, we can get an idea of what's going on with this velocity function by just connecting these points, assuming nothing crazy happens between those intervals. And since we're trying to figure out the displacement from t equals 2 to t equals 12, we're essentially just trying to find out, what the area is of this function from this point, so from here, on the right, up to here. When I say area, I mean that, I guess not a space, because in this case, or in these cases, the area will be a negative quantity when it's below the horizontal axis, and positive quantity when it's above. So we want to figure out what that total area is. Now, since we don't have an explicit expression to just find an antiderivative and integrate, we just break this into 5, or no, sorry, not 5, but break this into 3 trapezoids. We have one trapezoid here. The second one's going to be kind of weird. It's going to be like part of it is above and part of it's below, but we're trying to figure out this guy and then this guy. So we just add those three together. So if you want to figure out the integral velocity from, let's go, let me do this down here. Well, actually, I think I can cram it up here. So the integral of this velocity function from 2 to 12, that'll be approximately equal to a1 plus a2 plus a3. Again, I'm going to say that we can have negative area, to make this, easier to, understand. So a2 is positive there and negative here. a3 is a negative quantity. So we add those three, and we'll get an approximation for this integral. So using the trapezoidal, rule, we just figure out what the heights are for each of these. From 2 to 5, that's 3. From 5 to 8, that's another 3. And then from 8 to 12, that's a 4. And then so this will be equal to, this length plus this length, so 100 plus 40, divided by 2, times the height there of that trapezoid, which is 3. Now, if you need a refresher about how the trapezoids work in terms of, integration or the trapezoidal area, I showed it in the previous problem, so I don't want to just waste extra time. But go back to that if you need, a refresher on how we're calculating this. But this is b1 plus b2 divided by 2 times the height. So the second trapezoid has a positive base length over here, so we're going to have that as 40. This one goes below, so plus a negative 120 divided by 2 times 3. That'll be 3 again. And then the third one, this will be this length will be a negative 120, and this length will be a negative 150. Let me try to squeeze that in there. Divided by 2 multiplied by 4. And now let's just make sure we don't screw up on our algebra. So I'm gonna bring that expression all the way over here. So we're not cramming it. So 100 plus 40 divided by 2, so 70 times 3. So we're gonna get 210 plus negative 120 plus negative 270 times negative 270 divided by 2 times 4. So minus 540. So 210 minus 120 minus 540. So minus 450. Okay, so to reiterate, this negative 450 tells us that from the time t equals 2 to t equals 12, the train shifted position 450 meters in the negative direction, or, to the left, or, westward, you could say. Now, we want to figure out where it is from the position that it was at t equals 2. So if it was at 0, if it started at position 0, we could just say that the train is going to be at is going to be 450 meters west at t equals 12. So it's 450 meters west from origin station at t equals 12. But it didn't start at 0. It started at 300 meters east. So we're essentially just going to then add 300 to this. So we're going to go 3. The position at time 12, S of 12 will be 300 plus negative 450, which is negative 150 is our final answer. So the train is 150 meters west of origin station at time t equals 12. And you would represent that whole expression as, S of 12 was going to be equal to 300 plus the integral from 2 to 12 of v sub a of t dt. We got that to be negative 150. So just writing that in context. At time t equals 12, the train is approximately 150 meters west of origin station. It's really capitalized. Origin station. You need a little refresher as, why is it west? Using, let's draw a little compass. North, east. This west can correspond to like the negative direction of our Cartesian plane XY axis.